address in T6. We'll see that it's completely different for another vendor. Like if we take the other example, so the MAC address was in T0 there, but now it's in the table 2, and so on. So if you want your application to be independent of these details, you don't care if I'm using OpenFlow switch or a Corsa driver or whatever else. So I need to doing some match on these fields, and if this field exists, I will do some action, let's say. So if you have this MAC address and this IP address, for instance, drop the packet, or forward the packet to that port, or do some specific service chain, etc. So if you don't have this abstraction with ONOS, you need to add more code in your application in order to address this issue. So you will just make your code redundant several times, and every part of your code, it will be for a specific driver, and you will just copy this code and modify again with respect to the other driver it is in your network and so on. So if you have large heterogeneous network with the time, it will be a very complex and large and redundant code, and we don't want to see that with ONOS. ONOS, as we said at the beginning, is a modular system. We have several layers of abstractions. Every piece of code or every layer addresses some specific tasks, and don't care about the rest of the details, because it's the role or it's the function of other piece of codes or part of the ONOS subsystem. So, how to deal with that? We have, I would say, in the driver part, the pipeliner, and the flow objective service will translate the generic, let's say, ONOS pipeline, if we can say, to specific pipeliner that will do the rest. So if you have an application and you have one driver in your network and you want to add new support for a new driver or new vendor, you don't touch the application. You will just program a driver in the Southbound interface, and that's all. Your application is portable. So this makes the applications portable, which doesn't exist in the other controllers.
And not only your application is portable, but everybody else that comes after you and develops another application using the flow objective service and uses all the pipelines that are with a pipeliner in ONOS. So if you bring a pipeliner in ONOS, you're not supporting just your application, but you're supporting hundreds of applications that are built on top of ONOS. And this is also something very interesting for vendors, because instead of having somebody develop applications for their specific device, they bring in the device, they bring in the pipeliner, and they already have a bunch of applications that they can use with that device through ONOS.
So this is really one of the main, let's say, characteristic of ONOS. Do you understand it in general, let's say? Is it okay in general? Okay, great. So let's summarize a little bit. So flow objective is abstraction layer for application to be pipeline and aware. So we don't care how many tables do we have and what capabilities they can support. So gradual application and other piece of the code, which is flow objective, will do the rest. So it's enable, as we said just now, the application portability. And interoperability between different type of pipeline coexisting in a heterogeneous network, evidently, because you may have devices from multiple vendors. And this is one of the principles of the SDN in general. And if you don't have this concept, you are not following really a clean SDN solution. And ONOS does care of this point and makes it as clean as possible using these abstraction layers. Okay, as we said, if you want to support a new pipeline, don't touch your application, just write the pipeline inside your driver and that's all. Great, now about the Northbound, the last piece of code, the last slides are dedicated for the intent framework. Intent is, as we said, high-level, network-centric interface that focuses, as we said, on what to do or what should be done instead of focusing on how to do, if we can resume. So you will introduce your needs in terms of policies or high-level behaviors instead of introducing flow rules, because it's complex for any user. It could be not so complex for a developer, but it takes time, and we want to avoid pause situations. Okay, we will see a small video now that explains that the entity framework is consistent and persistent. If you have some failure in the network, it will deal with the situation dynamically. Let's explain the internet through the example. So consider that we have a complex topology, and I want to support a connectivity between two hosts. I want just to say, in some manner, in one line, or in some request, I want a host-to-host connectivity between this and this host. I will give the ID of the host. First of all, the application submitted through the internet service the request. Later, we have a compilation phase. So we need to compile the request. Why compile the request? First of all, we need to verify that this request is achievable. So maybe there is no path currently between these two hosts, because maybe they are living in two separated parts of the network. And maybe your request asks some bandwidth which is not available in the current links. So for several reasons, we need to compile your request to what we call installable intent. So we need to go from intent to installable intent. If it's installable, if it's feasible, now we will install the intent using an installer. So we'll install this using the flow rule that we introduced previously in terms of, say, open flow rules or whatever. So based on the use SPI, Southbound protocol.
But just to add to a point, so basically, what your application sees is just the host-to-host intent. All the work that Abdullahim explained is just done by ONOS. So after you call submit, it's ONOS that automatically compiles it and automatically installs it. You don't have to deal with that. You just submit a host-to-host intent.
It's completely transparent from the user, in fact. So let's go directly to the video. Okay, it's coming. So let's consider that we have these 6 devices and we have some hosts, and we want just to create simply an intent between 2 hosts. Can we go back a little bit? So we will see that we have two paths between, if you can make a pause.
Yeah, pause.
Okay. So we'll see here that we have, in fact, between this host and this host, we have path through switch 1 and switch P4, P1 and P4. And we have another path here. So the shortest path is there. So you will see that immediately we have traffic established over this intent connection or connectivity here. And we will see with time that these links will go down. And immediately the intent framework will recompile the intent and make it installable again through another feasible path in a very, very short time. And the traffic will be redirected to the new path in a transparent way. As a user, you don't care, and sometimes you don't know that it happens unless you do some troubleshooting. So, and it's a very dynamic system. Keep looking. We will have a lot of dynamicity in the network, and you'll see that the entity framework will deal with the situation. And here, look, the links go up again. But in order to avoid the disruption in the traffic, the entity framework by default will not change again the path to the shortest path. Unless if you enforce that by command line or by REST.
This is a very important issue, what Abdul Halim said, because one could think that since the link is going up, why not the intent go back to the previous state? The reason is that maybe the application that is running on top of the network is a critical one, for example, and you don't need to lose, you don't want to lose even a single packet. Let's say that there is a mission critical application. It has many, these type of applications are many, like for example, surgery from distance surgery, electronic with cameras and stuff. You don't want to lose a single image when you're doing work like that. In order to avoid that, you don't change the intent so that you don't disrupt the network. Even though someone would think you should go back to the previous state, it's not always the best thing, so you can do it if you choose to do it. By default, ONOS does not.
Okay, by the way, this work can be done by the command line interface as well, and you can do it using your scripts, RESTful or whatever, even without visualizing what is happening, what is going in the network. So it's a good example to show you what the GUI of ONOS, for instance, can provide for you.
So basically here what happened is that the top link went down, we were live on that path, so ONOS again recompiled the intent and pushed it back on the older path, okay?
So and again, in the performance talk, you will see some intensive experiments to evaluate the intent framework, and that can justify, in fact, that the intent framework is really scalable. So we are not talking about 10 flows in the network or 100 devices. We are talking about sometimes some millions of flows in the network installed using intent. Okay, great. So here we resume at any failure in the network or any change in the topology, we recombine the intents to search almost the new installable intent for the impacted intents by the update or by the failure, let's say, and later install them again over a new available path if it's a path request. And I just forgot to say that it's an extensible framework. We have some built-in intents like host-to-host, point-to-point, connectivity, etc. And you can easily extend this framework in order to meet some needs. Okay.
And if you're interested particularly in the intent subsystem, I suggest you to go and have a look at the Northbound and intents talk tomorrow, first talk of the ONOS basics here in the afternoon. He is going to present like how you produce an installable intent, what does it mean to extend this framework with new installable intents and new compilers.
Is it fine for this part?
Any questions?
Do you have any question before that we continue to some new things? Go please.
Regarding host-to-host intent,
yes.
Can I use point-to-point intent for the same thing? Like I specify MAC of 2 hosts and use point-to-point intent?
Yeah.
So, in fact, using the host-to-host intent, we will use, in fact, the path subsystem in ONOS to get a shorter path, right? And it's the ONOS who will do care on the selected path in the network, if this exists. If you want to, let's say, identify predefined path, you can use exactly as you say the point-to-point. So you say, okay, from this switch to this switch I have point-to-point, and later from this switch to that switch I have another point-to-point intent, and so on, until to the last one at the edge, until reaching the edge switches connected to the host. And later, when you run traffic between these 2 hosts, they will find their path without any problem. And we have the same configuration or same demonstration. After any failure, we will find another solution between to replace the failed, let's say, intents.
So recently, I observed one scenario wherein I created one point-to-point between 2 hosts, and there was a host moved event. So So
host moved event.
Host moved event.
Okay.
When that happened, the flow rules got deleted, but the intent state is in start state. It didn't move into like pending or failed state.
Well, that's certainly interesting for us. If you could get, if you're capable to reproducing this in a proper fixed set of steps.
Okay, I made this in the forum.
You can report that to the ONOS community, and the concerning brigade will be interested to searching what is happening and to if there is a bug to fix it.
Exactly. If we can see this fixed set of steps out of which this happens, we will certainly consider if this is a bug or we need to fix it.
Exactly, or you miss some configuration maybe.
Or
like
if
some
this is
treatment or
exactly expected behavior. So thanks.
What is protected intent, by the way?
Oh, protected intent, it's a very interesting thing. So basically, a protected intent, instead of installing just one path, it computes two paths and installs a primary path and a backup path. The primary path is the one where the traffic flows. The backup path, the traffic doesn't flow. But as you know, in a SDN environment, in our case also, if something fails, it's the controller that needs to take action and like install a new intent. But with this protected intent, since we installed two paths, we can automatically, the device automatically switches to the new path without having the latency to go to the controller. One example can be using fast failover groups of OpenFlow 1.3.
Thank you.
Okay? So I'll take it from here. And so now we've seen a lot of control of the network, a lot of like intents and flows and traffic shaping. But as you know, configuration of devices is also fundamental to any network operator. So ONOS has its own network configuration subsystem through which you're able to push JSON files for ONOS to understand and react upon. Then we have device configuration through behaviors, which I will talk about later. And then we also have dynamic configuration, which basically takes your Yang model and introduces it at runtime to allow dynamic implementation of dynamic services. So let's talk about dynamic configuration for a second. As I said, we realize that operators need a resilient and scalable platform capable of both control and configuration. So with the same platform, which is ONOS, we want to do control. For example, OpenFlow, controlling P4 enabled switches to P4 runtime, pushing traffic shaping rules, but also configuration. We want to set the power, we want to set the LEDs, we want to make any type of changes to a device through its configuration. So what we built with the help of a lot of our partners is the dynamic configuration subsystem. The dynamic configuration subsystem, basically it's done on three pieces. So a set of Yang runtime tools which take a Yang model, compile it properly, and generate a jar with this model that contains its, for example, Java-based representation of this model, plus some metadata. This model is brought in ONOS both at before ONOS is active, but also while ONOS is active. We have a very nice feature which we demoed in the last release demo, which you just bring a Yang model, put it into ONOS, and ONOS automatically will generate these Java classes for you. You just drag and drop to the ONOS UI. Then, on the right, you see the distributed configuration store. This is a persistent tree-based store that saves the configuration state of your device. In the middle, there are multiple components which leverage both the Yang runtime and the distributed configuration store to enable device certification applications, any type of applications to be modeled in Yang and be interact with ONOS through RESTconf, NetConf, REST and gRPC, but also on the Southbound do automatic serialization and deserialization of JSON and XML, think the netconf XML, through the Yang model. So basically, in the drivers, you can have an XML arrive from the Southbound, be automatically converted into Java classes, and use those Java classes to do whatever ONOS needs. So this is automatically done by ONOS for you, with a set of Yang tools, which you can find a lot more information on the wiki. And if you're interested in this, please join the Dynamic Configuration Brigade.
Before we move forward, let me add one more thing about configuration. I don't know if any one of you has tried in the past to configure a switch or a router, a legacy switch or a router, when it's working in a real environment. If you ever did, through the CLI of Cisco, for example, Juniper or whatever else, you must know that it's quite a challenge. And there are many people who can do it, but this is considered a special skill, and it takes years of trying to learn the way to do it, and it also has many human errors while trying to configure devices actually manually. So there is separate ways of trying to tackle this. One way is to make network automation software like that uses this CLI per vendor in order to address the problem of configuring multiple devices at the same time. This is one way, but this way is even simpler, and it allows a person that has no knowledge of CLI at all to configure complex network devices and make configurations that are required for a specific network to work.
There's a question? Yes?
So, is it probable this is a basic?
Can you bring your microphone
towards
your mouth, please?
Okay, so in this picture, is some, up there is some network functions there. But so what is the purpose of that element in terms of the ONOS?
Which element?
Network function.
Oh, so basically that is a network function that you can define in Yang, compile into Java objects in ONOS, and that is exposed to applications for you to interact. And also, not only that, but also network functions can interact with your Yang-based interface upon ONOS. Did I answer your question?
So that network function is logged in a switch element?
No, that is, for example, in a service orchestrator.
In a ONOS controller? Or?
No, it can be higher level. It can be an ONOS application that interacts through ONOS, through Yang, defined APIs, but also a different element in a separate system that interacts with ONOS.
It could be, in fact, load balancing function, for instance. Yes, or packet filtering, or whatever you want.
And such as routing protocols, it's OSPF or BGP. That is one of the network functions. Is it right? Or
it's a network function, but most of these basic functions are already supported and implemented in the core of ONOS. And they are, we have some APIs to, for instance, verify or configure routing if you activate the corresponding applications, which is, for instance, BGPLS or whatever.
Can it also be PCE?
Path computation elements? Yes, there can be, but all these protocols are kind of live in the ONOS Southbound. On the Northbound is more high-level network functions. And to better get a better reply to this question, please write on the Dynamic Configuration Brigade mailing list. They will tell you what you can do on the Northbound and what network functions you can bring in and how you interact with those.
In fact, for the BCP path computation element protocol is the southbound interface, and the main objective is to support the current working routers like XRV from Cisco, for instance, running in the data centers to support the migration from the legacy one solution, let's say, to SDN one solution. So these routers that doesn't support, for instance, don't support OpenFlow or netconfig, but So it has the PCC element, the client of the PCOP. So using this Southbound protocol, we can communicate with these legacy devices, which is running in the operators' networks, and operators don't want to remove all these elements or these devices at once. They want to remove these devices one by one and to go with a very slow process to SDN solution. And for that reason, we had a brigade from Huawei dedicated to implement the PCOP for this specific objective. So it's a Southbound protocol. You can use JSON files to configure your routers.
Exactly, like as you see here, it's mentioned, PSAP, Path Computational Element Protocol from IETF. And this is the list of protocols that ONOS supports in the current 1.11 release, which is OpenFlow 1.3 plus optical extensions. 1.5 is implemented and under testing. We're struggling to find any OpenFlow 1.5 devices. That has to be said. We have OVSDB, NetConf Yang Tools, Yang Management System, and the dynamic configuration, SNMP. We have P4 runtime to deal with P4-enabled devices. We have BGP, SAS, OSPF for legacy networks. We have PSAP, REST and RESTconf, Lisp, TL1, and now we have also gRPC Southbound, as was discussed this morning.
Just one more thing about the legacy networks that Andrea mentioned. The fact, for example, that ONOS supports BGP or OSPF is very important to actually the network operators and the networks in general to use ONOS, because you cannot change everything overnight. You cannot go to a network and say, rip everything away and we will use my switches and my controller and you'll make it everything my own way. Everything, as Abdul Halim said, must be a gradual process, and the support of the legacy protocols is very important for this reason and for this goal.
Yes, so how does the ONOS Southbound work? So the ONOS Southbound is where all these protocols are implemented and proper abstractions are given to the ONOS core in order for the core to be protocol, device, and model independent. Okay? So we have providers, protocols, and drivers. Providers hide the complexity from upper layer and react on the network. The protocols are just the modules that enable you to communicate with the device, and the drivers instead define specific capabilities offered by a device. So the protocols are just used to communicate with the device. They expose the standard set of APIs and of that specific protocol and enable that specific protocol operations. So you have, like for OpenFlow, the protocol offers means to do flow mods, group mods. In REST, you have the get, set, post, delete. In NetConf, it enables you to open and close the session, set the configuration, get the configuration, and all the NetConf 1.0 and 1.1 supported operations. And this happens for all the protocols that you see. We usually leverage third-party libraries to do this. SNMP4J, Thrift, OpenFlowJ, Apache Nina for SSH and NetConf. Then, the providers are the part that actually react on the network. The protocols are the dumb element. They're just the ones that are the pipe to communicate to the device. But where, like, the up and down of the device and links is handled is the provider, the device provider, link provider. Then here is where we provision the rules. We have the provision path, tunnels. Also, we process packets. We have notifications and alarms. Basically, the providers, the key element is that they translate from core abstractions into protocol and behavior calls. So let's talk about the drivers. This is where the integration for a specific device comes in. Because, as you know, the protocol is just a general, as I said, pipe. NetConf is just, okay, open and close session, get an edit configuration. But what do you want to do with that specific device? It's written in the drivers. In the drivers, you specify how to do an operation on a device. So a device has a driver in ONOS, and that driver is assigned to the device in particular through manufacturer, hardware version, software version. And the driver is a collection of behaviors. A behavior is an interface. Basically, a behavior encapsulates the specific capabilities offered for a device. For example, it has set LED, and that set LED is the API. Then, in the implementation part, the given device vendor will bring in his way to do the set of the color of that LED. Basically, then the application, if he wants to do the specific configuration, interacts with the API and not the implementation. You see the recurring pattern here? Your API and your application don't change if Sienna wants to configure the LED in a way and Juniper in another way. That's very important. And all this subsystem mechanism is what enables ONOS to be such, enables ONOS applications to be such independent of the network. So some key behaviors that we use in ONOS to do some very important elements. Device description discovery. Discover what is the device, it's for. FlowRule programmable. Translate the ONOS core concept of the flow rule to any call to your device to make that match action happen. Packet programmable. Emit a given packet. Group programmable. Translate back and forth from any given action on the device to the groups. Port statistic discovery. Discover like packets that go through a port. Or the pipeliner, as we said before. We translate flow objective to pipeline specific flow rules. Then we have like the device handshaker that enables you to create handshaking with a device with a very generic protocol that you want. And the pipeline programmable. This install a pipeline on a device with, for example, P4 enabled switches. So let's give an example. How does this whole thing work? So your application or ONOS subsystem requests for a flow rule. The flow rule, in the case, arrives to the flow rule manager. In the case of OpenFlow, it's a one-to-one mapping between the ONOS core flow rule and the one on the device. So the OpenFlow flow rule provider just sends it to the device. But then ONOS receives this flow rule for a different type of device, which is a netconf device. Netconf devices don't have the notion of flow rules. So how do we install them? Basically, we have a flow rule driver provider that goes to the driver service and asks for a specific behavior, the flow rule programmable. If there is an implementation of this flow rule programmable, it gets it and uses it to translate flow rules into, let's say, netconf specific XML to, for example, install a static root. And that is how your device can do kind of a match action. But your application doesn't know all of this. It simply asks for a flow rule for a specific device. And this is it's a key piece component of ONOS. And also, how do you choose the proper provider and driver for the device? It's all based on the device ID. You see OF and the MAC address, netconf, username, IP and password. So the first part is the URI. You use that to choose how to install the proper rule on the device. So let's talk a little bit about applications. We built the platform. So this whole talk until now, it was building the platform. On top of the platform, we have applications. Sorry, I didn't ask. Is there any questions on the ONOS Southbound before I go forward? No questions? It means that I was or too good or too boring. Okay. If you have any questions, you can also find us during the whole event and ask us some questions. And if we don't know it, we will point you to the proper ONF person that knows it, such as Thomas, which is sitting in the audience. So, applications. Let's talk a little bit about it. So we interact, ONOS applications, we have two types of ONOS applications. On platforms, ONOS applications, which interact with ONOS through Java. They live in the same ONOS JVM, and they're very fast to interact with ONOS. Then we have REST and gRPC in applications that use just REST and gRPC to interact with ONOS, and they are called off-platform applications that live in whenever you want, and interact with ONOS through REST and gRPC. All these applications are device and protocol agnostic. If they are on-platform applications, so they interact with ONOS through Java, they augment it through modularity, bringing in, for example, distributed stores and stuff like that. They can provide themselves graphic user interface, REST and CLIs. They can shape the network based like traffic programming, flow programming. And it's also, as we will see later, they can be auto-generated with some basic code via Maven archetypes. And this is a key element because it enables you to just put the intelligent logic in the application and don't care about like the boilerplate code that you have to write.
By the way, after this talk, we will have a practical session hands-ons on how to install and run ONOS. And just after, we will teach you how to build a simple application using ONOS. So if you are interested in how to build an application, please keep in touch with us and charge your laptop after the installation session.
Make sure you download the VM if you haven't already, and yeah, we'll take it from there and help you do all the other things, the installation, the applications, and everything in the next sessions.
So some example application, SDN-IPP ring, which basically exposes ONOS through a set of BGP speakers, like an autonomous system. So other autonomous system can connect to it and let traffic flow through it, and ONOS will deal with the rules internally of its own switches. We have packet optical provision, direct TV, VNG, bandwidth calendaring. This is an ongoing list. We have plus more than 130 ONOS applications. So I bet that some of them will fit your needs. Just to finish on a side note, which is to me very important, is how do we test ONOS? Because, you know, we give it out, it's open source, Apache 2.0, you can download it, play with it. But we need to test it. So there's a QA team that does it, but we also want physical deployments. This is what this slide's about. Basically, we take ONOS and we work with the national research and educational networks to deploy it on their real hardware and network. And we give them the code, they give us feedback. And we give them better code, and they give us other feedback. And this is a loop that continues on and on for us to improve ONOS and for them to get a better product. And this is the same with our service providers, and this is the same with our vendors, and this is the same with every part of the community. We leverage the feedback from the community to make a better ONOS.
And by the way, we need your support to improve the wiki of ONOS, for instance. We are all here, all of us, members of the teaching brigade, and for instance, one of our aim is to improve the wiki page of ONOS, which is already good, but we need to reorganize everything in a modular way. We'll talk about that tomorrow. And if you try to test any page on the wiki, or even any external tutorial, and you find any problems, please report that problem to ONOS Discuss or Teaching Brigade mailing list, and we will help you, and your email will help us to improve our documentations.
So the idea is that we don't want you to be an expert on ONOS in order to attend and join the teaching brigade. We actually need people who will try the wiki, who will try the documentation, who will try stuff, make and break stuff, and report about it. And these people are willing to write about it and report to others what they found. So you don't need to be an expert. I will repeat that. We will need people to test, to try, to make and break stuff, report stuff, and these kind of people are the perfect for us, for the teaching brigade. So if you want to join us, come meet us, and we'll be a group of all the people working for ONOS and the teaching brigade afterwards.
For example, deployments in Korea, ClearNet. You can go have a look. And and all these are connected through over EGP overlaid to dedicated circuits. So we've talked about like what ONOS is, its capabilities, abstractions, southbound, northbound. Let's get down to business. What do you need to run it? You just, obviously, it depends on your cluster size, so number of instances, the manager network size, devices, links, and ports, the messages exchange, the number of flows, how big is your network, okay? But basic requirement to run ONOS in production are 2 core CPU, 2 to 4 gig of RAM, 10 gigabyte hard drive, and 1 NIC card, any speed. This is a server requirement. The development requirement, Linux machine, actually Unix machine. You can run natively ONOS to try it out, both on Linux and on Mac OS. I actually develop on Mac OS. I run ONOS locally on my machine, and it works perfectly fine. On your machine, you run a single instance of ONOS. In a server, you put 3 servers together, you run 3 instances. So, we come to an end of our talk. It was a long talk, an hour and 24 minutes and 40 seconds exactly, since my timer is telling me. And so we can end 5 minutes earlier. But do you have any questions? I know it was a very long talk, but we would like to take some. If you don't have them now, you can always review these slides, because they will be on the ONOS Build website, and I'll put back the slide with the link now. So you can download them, and you can come see us tomorrow, Friday, or send us an email. Our emails are these. It's very simple. So us at ONF are such a small organization that we are lucky enough to get just a name on the email. It's Andrea at Open Networking, and then Lefteris is manasakis at gmail.com, and Abdulhaim is aidandush at gmail.com. Write us an email, send us your thoughts, both on the talk, on like what we can improve, and any question on ONOS is very much welcome. These are some links at which you can find resources for ONOS at. ONOS Protocols is the website, the wiki is where you get technical. The code is on GitHub. Go there, Apache 2.0, download it, modify it, do whatever you want. Setup tutorial, which we will run later, installing and running ONOS. And some very, very good videos that were made by Tom about how to run, install, and also create your working environment on ONOS can be found at our ONOS project wiki page /screencasts, and they will point you to the YouTube account. And you can see them like very basic videos that discuss what you can do on ONOS. So, thanks everybody for staying with us.